Mechanical advantage and friction. Here are two scientists, Professor A and Professor B. They are both equally strong. And here is a very heavy book about science. We are now going to perform a scientific experiment. We are going to find out which of the two professors can lift the book with the lesser amount of force. First, Professor A. 24 newtons of force. Now, Professor B. Only, what, 6 newtons? Well, there's no doubt about it. Professor B is the winner. You're quite right. It's not fair. Professor B had an unfair advantage. He used a machine, a lever, to give himself a mechanical advantage, in fact. But just how much mechanical advantage did the lever give Professor B? It's easy to work out. Both professors lifted the book to a height of about 10 centimeters. Professor A lifted it straight up, so he had to pull against the full force of gravity, which was pulling the book down. But since Professor B's lever arm was 4 times as long as the arm the book was resting on, he only had to pull with 1/4 the amount of force, 6 newtons instead of 24. In other words, his input force was 6, and his output force was 24. And all you do to calculate the mechanical advantage of a machine is divide the output force by the input force. So Professor B's lever had a mechanical advantage of 4. You'd like us to repeat the experiment, Professor A? You think you can equal Professor B's feat of lifting the book with a force of only 6 newtons? Very well. Professor A is now setting an inclined plane against a block of wood 10 centimeters high. And the inclined plane is 40 centimeters long. Fine. That's 4 times the distance, so it should divide the force he needs by 4, which means that his Newton's spring scale should read 6. What's this? 8 newtons? Well, there it is. Professor B is still the winner with a force of only 6 newtons, thanks to the mechanical advantage of 4 given him by his lever. Whereas with Professor A's inclined plane, we see that he has a mechanical advantage of only 3. Why is this? Why did the inclined plane have less mechanical advantage than the lever? Because of something we've forgotten about till now, the force of friction. Every time something rubs against something else, there's friction. In theory, Professor A should have been able to pull the book up the inclined plane with a force of only 6 newtons. But since friction was pulling in the opposite direction with a force of 2 newtons, the professor's pull had to total 8 newtons. Professor B, on the other hand, was lucky because the amount of friction between the point of the fulcrum and the lever arm is almost 0. So the lever is a more efficient machine than the inclined plane, because the inclined plane is plagued by the demon friction. But friction can be an angel as well, of course. Without friction between the tires of your car and the road, you wouldn't be able to drive. Or stop driving. Just as if there was no friction between the soles of your shoes and the floor.